This is the second video in this series as I'm hoping to build up a PCB to support a Zynq-7000 sock. And in this video, I thought I would just provide some updates I've made, especially to the power setup, just some minor updates there. I've done some other very small incremental work, but then I've also gotten into trying to figure out which components, what are the major components I need to start thinking about on this board. Now, as I'm going through this, just as a reminder, this is all extremely new to me, so I'm kind of learning my way through this, and I'm sure every week I'll learn something new and come back and modify something, and I've had all kinds of good advice along the way from many of you, so please keep that coming. I'll do my best to incorporate changes that I can. I have been going through some online coursework with this FedEval. Really, it's a Phil from Phil's lab that's teaching a couple or recorded a couple of courses in here, and they've been really good. And the one I'm going through right now really is him building out a similar type of board. So he has a board that he uses as part of that course to build out this Zynq-7000 sock type of little board. And mine is going to be different than that, but there's definitely a lot I'm learning from it, and definitely many aspects of it I will try to leverage, along with other samples that either have been recommended to me or I've been finding. So I've added some additional ones down here in the notes. But between, I would say, Phil's course that I'm going through and then the schematic for the Arty Z7, those are probably the two most helpful things, along with Phil's other videos out on YouTube, the free to access videos. But maybe here in this number 2 video, what I'm going to do is jump over. I've started this essentially a whiteboard just to help me keep track of, maybe there's changes I made since the last video, and I'll talk through those. And then the next video I come to, there'll be a different list of things maybe I worked on in between videos. Some of these videos will just kind of be an update. I'll show what I've learned, maybe the direction I'm going. Maybe other videos will be more me walking through connecting up something. For example, I think the next video might be me trying to connect up the flash and maybe get into the DDR, or do the DDR the video after. The other things in this whiteboard that I'm going to track, what do I have upcoming? Things I know I'm going to have to work on and possibly have a video on, and then maybe just some general to-do. This is kind of a little backlog list that will grow probably faster than I take things off the list, but at least I have kind of a holding spot for ideas or things I know I need to do. And then maybe over here to the right is just, a high level start to an architectural diagram, or, that high level, what is it that I'm trying to put on here? And this is not done, and this will be an ongoing living type of diagram. I know for some that you would argue that you should have that entire high level, architectural view done before you even start, but I don't even know where I'm going entirely. So, I can look at Phil's sample board as an example. I can look at the Digilent sample board as an example. And those both give me ideas of what I might want to be including. But, this is not done. This will change, and I'll continue to build this out as I go. And if along the way any of you have ideas of major or maybe even minor things that I'm not talking about or calling out here somewhere that I should be thinking about, do let me know. So if I look at this real quick, what I'm looking at is the main processor I'm using, this SOC / FPGA, the Zynq-7000 that I'm working with. And I want to have power come in both through USB and through a DC barrel connector. And right now I have 4 regulators set up, or DC to DC converters, maybe is a better way to say that. But I have my 1.0 volt, 1.35, that will be for my DDR3 later when I get to that. And I suppose I could say DDR3L. So the lower voltage 1.35 DDR. I have a converter for the 1.8 and 3.3, and then the 5 is what's coming in. And I'm going to make the assumption that the 5 volt coming in is regulated either from USB or from my benchtop power supply coming in. And then, of course, going through these converters, this coming out, these 4 voltages should all be pretty clean voltages. And I don't know if I'll even use the 5 volt anywhere else other than to feed these 4 converters. Things I know I want to have on here, I'm going to need a QSPI flash, and I've selected that specific part. I'll talk about that in this video, which one I think I'm going with. Same with the USB bridge or UART, dual UART. High-speed PHY, this USB ULPI type of connectivity, Ethernet PHY, and then SD card I think is what I want to do. Now in Phil's design, he's using some other type of persisted storage that sits on the actual PCB, but I think I'm going to go with something simpler for me, for now at least, just an SD card. And then I'm looking at a pair of DDR3L chips, and I think I know which ones I want there, and I'll talk about that in this video. And then I know I've got a bunch of little miscellaneous things. I probably will have an oscillator or two somewhere on the board, things like a reset switch, LED indicators. I've been using these 68-pin expansion connectors. I'm going to assume I'll have 1 or 2 of those at least on this board. And then a JTAG connector. Expectation is programming is what will be done through USB, but I still want a JTAG connector on the board. So maybe let me talk through some of the changes I made. And the first one is I've done a little bit more work in the schematic, and I have a lot to do here, but I'm going to try to make the schematic a little more readable, a little more friendly as I move forward. What I've done so far is I've further split the schematic out. I have this first page that's just a placeholder for some of the major parts, and from the last video you'll see many of those disappeared because I've now separated them and brought them into, for example, a page on the dynamic RAM or DRAM, USB, Ethernet, processor, programming port, HDMI, etc. And I'll just slowly work these out into other sheets, and this list of sheets will probably grow. And for the most part, I'm just setting up 11 by 17, so or 17 inch by 11 inch sheets that I'll be working with, and that's a size B that I'm working with. For those of you outside the US, that's probably fairly close to an A3 size of paper, but B drawing size is what I'm going to use. And I find that these are still very readable. I run a 4K screen, and I'm sure many of you have figured that out from my videos, that pretty much everything I do is in 4K. So these sheet sizes are easy to read on a 4K monitor, and also easy to print on a 17 by 11 sheet of paper. Not that I really ever print these on paper, but if I did, it would be easy to do. So over here, that was one of the things I did, was set all the pages to this size B, and then also split out the schematic into more sheets. I've also started the decoupling capacitors, and if I come down here, I have my regulators or converters here, my buck converters, and then I have a power sheet, and in that power sheet, really I pulled in the blocks from the sock that have to do with power, and I've started connecting this up. This is not final, this probably needs some work, but essentially I'm trying to get all the different capacitors in here. I have some larger capacitors that are going to be like a tantalum type of capacitor. I've got some smaller capacitors, whether it's a 4.7 or a 470 nanofarad, whatever. So 4.7 microfarad, 470 nanofarad, or other sizes you see, other values, capacities that you see throughout this. There is an analog ground down here. I don't know if I'm going to do anything with that. I don't think I'm going to do any analog on this board, but there is an analog ground there. I'm not doing anything with analog power supplies. I'm really trying to stick all digital at this point. But I've got these capacitors laid out. And for the most part, these larger 100, these again might be a tantalum type of a larger physical package. These 4.7s I'm going to do as a 0603 for size. All the smaller are going to be 0603s. And I'll do more reading and just maybe adjust these values, maybe adjust the size, possibly the 4.7. I want to go up to a 0805 package. I don't know yet. 0603 is not a problem. I think I've got plenty of 4.7 microfarads in a 0603, so that's probably what I'll do there. But it could be that some of these I actually go with a smaller than 0603, maybe a 0402 if I want to try to solder on the very bottom of the FPGA, or the sock in this case. But we'll see what I do there when I get to that. So then I have my regulators, and over here I mentioned that, okay, I've gone through and I've updated this schematic. I've done those things. I've added some decoupling capacitors, more to come. And then I've made some regulator / inductor adjustments, and also started the power sequencing, which I think I have in place. So if I come over here and I look at my buck converters, the very first one that I want to bring up is the 1.0 volt or 1V0. And I'm sticking with this TPS 56628. Again, this is a SOIC. It does have a large open ground pad on the bottom of it for heat dissipation. But this first one's going to fire up, give me my 1 volt, and when it signals power good, that will then enable the next one. And the next one is going to be my 1.8. When that's got power good, it'll turn on my 135, and when that power is good, it'll go over to my 3.3. And so I think that is the order that I'm going to use. And I do need to double check that, but that is the voltage order, or the bring up order that I've got so far. Something else I've done is I've actually come in here and chosen the real inductors I think I'm going to try to use. And I guess I don't even have it marked in here, but I'm going to use a 2.2 microhenry on these first three and a 3.3 over here. And I didn't necessarily indicate which specific ones I'm going to use, but this is an INPAC AIP 053GX, and in this case a 2R2. And so that's what I'm going to use for this one right here. And actually that'll be the same for these all the way through here. And maybe I'm going to shortcut this a little bit. That's too much in here. And then this one over here is a slightly different one, of course, if I'm going with a 3.3. But I created in my devices, I just made my own inductor, which is an INPAC AIP 0530GX series. And basically both of these inductors, this 2.2 and the 3.3, are in that series. They're the same physical size. So I just came in and I created a footprint for that. I created, the appropriate schematic for it. I could not find a 3D model. I'm actually trying to get the real 3D model for this one from the manufacturer, but for some reason they don't seem to want to share it. Maybe I'll get it eventually, but they don't publish it. So I just found one that was very close in size and brought that 3D model in and applied it to this. So this is my custom device with my little schematic symbol that you see here. And then when I get to the footprint, you'll see that footprint I've maybe customized it a little bit to make it a little bit larger than necessary, just to give me a little flexibility. But that can be dialed in later. So between the sequencing of these four, along with changing out the actual inductors, that was what changed on this specific sheet. And then I've been working through, again, I had all of the decoupling capacitors. Here's my DC barrel connector. I do have 3 jumpers, so I can choose between either the 5 volt coming from the USB or 5 volt coming from the DC barrel connector. And, just researching this, and one of you had responded in YouTube too, that typically these jumpers can handle 2 amps if you trust them. And so if I was going to have a full 6 amp supported type of board, which I can't imagine ever getting that to that type of current, 3 of these though would be more than enough. And honestly, 1 jumper is probably all I need, but I've got a couple extras there in case I want to use them. Coming down on this, I've also added in the actual portion of my sock that has to do with connecting to the DDR, and I'll be using DDR3L, so a low power DDR. And this is the one I'm going to go with, is this MT41K256M16TW. So that's a lot to say and go through, but if any of you want to Google that, and I think over on my blog post, I've been keeping that up to date. So if you want to come over here, you can click this link, and this is the one that I'm using. So it's a Micron, and it is this one right here. So it's a 256 meg by a word by 16 bits. And I'm going to use a pair of those so that I can run 32-bit. And that's what you're seeing here. And I've only just connected in like a low address, a high address, and a low data, high data, just to kind of see where these are at real quick visually with the rat lines on the PCB, just to start to do some basic placement. But I need to come back in a future video and actually do all the connectivity of this. And I don't know enough about all the signals yet. I mean, obviously address and data lines are pretty straightforward, but beyond that, I need to learn a bit. So I'll come back to that. On the USB side of things, again, I did look to do a few things here. So I've got a USB connector, a USB-C connector that I'm going to use. And then there's this FT2232 that I'll be using along with this USB 3320. And on my blog page, I did list these out. So I've got this USB bridge and then this USB transceiver chip. So that's what those two will be doing. And then there's also this Ethernet chip that I'll be using, this Realtek RTL8211. And that I've put over onto this Ethernet page. And then I know part of the sock is a whole lot of the processing system, a lot of these PS type of pins. So I just brought this over onto a sheet. There is part of it to connect up to do the programming. So I brought that onto a separate sheet. And then I'd like to have a pair of HDMI connectors, an actual input and an output. It would be really fun at some point to bring in video and overlay or do something with it, manipulate video and send it back out. So I know I can do that with my Digilent board, so I thought it'd be interesting to see if I could do that with this as I build it out. But with all of that, then if I go over to my PCB design, and looks like I made some changes. Yeah, so I'll just say okay to that. And this is what it looks like at the moment. So, here is again the sock, and on the bottom layer, all the blue stuff here, you can see I've got capacitors all over the place, and I've quickly placed those for now. It probably needs some cleanup, and I'll come back to that. There might be some sizing adjustments I make. And like I said, maybe if it makes sense, I could have some capacitors on the very bottom when I get into some of the power stuff. But I'm not going to worry about that until quite a bit down the road to do that fine tuning. Over to the right, I have the HDMI connectors, and I just placed them there for now. All of this is subject to change as far as movement as I add more pieces. Here I have a pair of those DDR3L chips sitting here on the bottom, and those initial connections I made just helped me understand that really this stuff is sitting on the bottom part of this sock. Down here is where those signals are going to be coming out of, so my RAM will probably sit down here somewhere. And that RAM requires a 1.35 volt, so this is the DC to DC converter and the inductor to get me that. And this is that custom footprint that I made up for this inductor. Really, the inductor just uses two little slices right here, but I wanted it to stick out a little bit for soldering purposes, for hand soldering. And then I also want to give a little extra room in case I want to go with a slightly physically larger one if I needed to for some reason. I've got some room for adjustment there. Over to the left, I've got my 1 volt, my 1.8 volt. Those I think sit nicely over here. They're spread out enough. And then I also have my 3.3 volt up top at the moment. And all of those I'll fine tune as I know where things are going to sit. Here's these jumpers that I can choose between USB power and the barrel, a DC barrel connector for power. So I can maybe just have a single jumper to start and pick one or the other, and I'm good to go. But if I want to kind of triple my connectivity in case I'm worried about a 2 amp limit, I've got some additional jumpers I can put on there. Obviously, I wouldn't want to connect both USB and barrel at the same time, so it'd be all 3 up or all 3 down type of thing. But my DC barrel connector, a USB-C connector, a couple of these chips to support the USB stuff. This would be my Ethernet RJ45 connector and that little Ethernet controller chip that sits right there. None of that, of course, is connected up, and that's all stuff I've got to figure out. I know the routing for all of this memory is going to be interesting to say the least, so I'll have a lot to learn on that, trying to get that all done correctly. And if I look at this in a 3D view, just to kind of give an idea of what this starts to look like or feel like, again, this is a 100mm squared board. So I've got a little bit of power sitting over here and some up top. It could be that I try to move these little components a little bit and get this stuff closer to the edge. That probably is going to be easy to do if I want to. And I don't know exactly where the placement of these will be, how much room I'm going to need to do, how close can I get. Maybe I can get pretty close, but I imagine I've got some stuff to figure out there. My HDMI connectors, my DC power, my Ethernet, and a USB-C connector is what I have so far. Looking at the bottom real quick, you can kind of see how I have these capacitors, at least for the time being, set up. So I've got some physically larger capacitors and then a whole lot of 0603s of the different voltage rails spread around this. And you notice I don't have any of those capacitors around any of these ICs yet, like these 3 over here, or these 2, I guess the pair down here for memory. So that's all stuff that will come later. I've not put any of those into this yet. So I think that is what I've made for changes. If I go back to my whiteboard for a second, that did get me through my regulator and inductor adjustments, and then again that power sequencing is also done. So I'm just going to clear all that out. I think in the next video I'm going to try to get the flash connected. And did I not have that flash on here? So I have selected the flash chip I want to use, so maybe I'll add that here real quick. So the flash chip, if I put it on here, which I thought I did, I must not have put it in my notes yet. So it's going to be the same one I've used on some other projects, which is this WinBond. So let me go find that in one of my other projects real quick, just to make sure I get the part number right. And so I'm just going to pull up one of my older projects. Let's see, I had a 144 pin ICE-based FPGA, and that used the same serial flash that I'm going to use on this new project. And let's see if I come over here, that's this one right here, this W25Q128JVSIQ. So I'm going to grab that and slide that into my other project. And for now, I'm going to put that under program. I might change that later, but that is there. I can then update my PCB. And I don't know where this is going to sit yet, so maybe for now I'll just let it sit right here. And then, of course, if I go look at that 3D wise, you'll just see that I've got that little flash chip that I'll program when I'm working with this. Now, some notes. This flash chip, you do have to be careful which one you select. And I did find that in the documentation, there is a Vivado Design Suite User Guide, Programming and Debugging. It's UG908 is the document. And it does include very specific SPI compatibility for Flash for this specific, series, the SOC series that I'm using, the Zynq-7000. And this one that I've selected, I should be good to go. That should be compatible there. And speaking of compatibility, RAM is also something to be careful of. I did fire up the latest version of the Vivado software, and it's been quite a while since I've used this, so I had to actually go download the latest. The last version I had was from, maybe 2022. It was old, from old projects I'd worked on. So I did go get 2023.2. I real quick just created a block design and brought out one of the Zynq processing system components out here. But the reason I did that is if I go into this, I can then, let me make this bigger. I can then come in down to the memory interface and go to the DDR controller, and I can tell it that I want to use DDR, and I can pick, DDR3, the low voltage, as an example. And then I can go to the memory part and see if the one I want to use is in the list. So this is kind of a out of the box. All the timings and other information is set up here in Vivado to use one of these. And if I go back to the one I selected, it is this 41K256M. So 41K 256M16. So it's this general part here that I'll be using. So it's in the list. I think there's different flavors of speeds and stuff like that, but I think I'll be okay that I can come in here. I can see there's two different ones here, a 125 and a 15E, and I'd have to validate the one I'm using, specifically which one it best suits that. Now, of course, you don't have to use what's in that list. So when I pull this back up and I go down to say that I want to do DDR low voltage, and let's see, can I make this wider? Yes. Okay. If what I want to use isn't in that list, I can always choose custom. And then I can go through all of the memory configuration and read all of that from the data sheets and plug it in. So it's not like, even if I pick one that isn't exactly in the list, I can always fine tune it if I need to. Now, each of those is 16-bit. A pair of them then should give me my 32-bit. So that's this effective bus width. So I'll do a pair of those. That'll give me my 32. So that's what I'll be coming back to at some point. And, again, on my setup over here, what you'll see is that I'll run all the address lines the same to both of these, but then half of the data lines, the lower word will go to one, the other half of the data lines, the upper word will go to the other, to the 16 and the 1632 from over here. At least that's the intention, and we'll see how that all plays out. So that's where I'm at, and I'm going to stop there. And I think next time when I come back, like I mentioned, I think the next thing I probably need to get into would be getting this flash connected up, and then getting my DDR3 connected up. And the flash will be pretty easy for me. That shouldn't be a big deal. DDR, we'll see what I learn there. And then as I get into USB, HDMI, Ethernet, that's all going to be new stuff for me. I think the HDMI is pretty straightforward. I think that's just all connecting right to the sock. But the USB, there are a couple of ICs in there, and Ethernet, there's an IC that I've got to work with. And I don't know yet on the SD card. I think that's probably a relatively direct connection to the sock again, but I could be wrong. So stay tuned for more to come in the next video.